Okay, we're back to absolute value functions motivated by Sarah's questions, and this will be part 4. So Sarah has asked about the piecewise way of expressing a function like the absolute value of x squared plus 4x plus 4. She has recognized that that is a quadratic inside there, thus a parabola. And I think that she might have pulled this example maybe out of her own brain, because in this particular example it's kind of exotic in that it doesn't work the way the average question like this might work. So let's take a look at generally what I would do about this. So I have my tool is my graphing calculator here, Sarah, and I've graphed x squared plus 4x plus 4 inside absolute value signs. If you don't know how to do that, my calculator shows the actual absolute value signs by pressing math, going over to the right once, and then selecting absolute value, which is the first selection in the number menu. But you probably will just get the letters ABS bracket. So don't be alarmed if I can get this and you can't. My calculator for some reason is more advanced than any other ones that I've had. Okay, so on my screen I have placed this. Now I know a little bit about that function before I even begin to use my calculator to think with it, and that is that that function is always positive. And if I factor it in my head, it's x plus 2 in brackets squared. I'm thinking fairly quickly there, but that's not the focus of my thoughts, so I'm not going to elaborate on that. That means a 0 of negative 2, and it means that, very badly drawn, that this is what I can expect to see when I do my visual estimate, my mental mathematics with my graphical experiences that I've had. And I know that there's this 0 at negative 2, and I know there's a y-intercept of positive 4 because that's the standard form of the quadratic that I see inside there. So then if I know that and I ask myself, okay, whenever it's negative I have to bend it upward, well, guess what? This thing is never negative. So that's not going to be a very complicated piecewise function to write. For all values of x, the absolute value of this quadratic, I'll just get my pointing tool, the absolute value of this quadratic will be in fact this equivalent to y is equal to x squared plus 4x plus 4. Okay, so that may not have been obvious to you when you asked the question. So let's just look at how we might go about this if it weren't such a friendly quadratic in there. That quadratic is very familiar to us. We know it'll always be positive because every term inside there has to always be positive. And then we have some experience with that one. It is in x plus 2 in brackets squared. Okay, so to speak a little bit more about that, I took that into my graphing calculator and I graphed. What does it look like when it's just x squared plus 4x plus x? And I made that a bold line by arrowing over to this side of the y2 and pressing enter until I got that bold line. And then for my third, I wanted to know what negative of that function would be, because I knew that if I needed to use a piece of a function, it would be that piece, okay, a piece of that function. And then again I changed on this side over here, I changed how it would graph by pressing enter on that side of y3. Okay, so those are the three things that I have in my graphing calculator, and this is the graph I saw. So what happened was y1 graphed right here as I predicted, y2 graphed on top of it, so by changing it to bold I could see that happen. And then y3 graphed down here. I can see from this graph I don't need y3 at all, that in fact y2 is sufficient. For all values x, the two functions in y1 and y2 are equivalent. So piecewise function is an odd thing to request there because I don't need a piece of anything else but the original function. So I think it's important to maybe try a different example, which I'll do in my next video.